Let's talk about radioactivity. Okay, now see, if a nucleus is stable, it's a very good thing because the atom can stay alive as long as the nucleus is stable. If the nucleus starts to disintegrate, if the nucleus is unstable, then atom no longer exists. Okay, so it's as good as this one. So whatever we talk about, in the last video you understood about nuclear stability, correct? So in this one, we are going to talk about what if the nucleus is unstable. What is going to happen? This is where radioactivity comes into play. Okay, suppose if you have an unstable nucleus, what do? They start to emit different types of radiation. That means there is a spontaneous disintegration of the nucleus. This is what we call as radioactivity. Okay, and whenever we talk about spontaneous disintegration of the nucleus, it is not because of some external force, it happens by itself. It is the property by virtue of which a heavy nucleus disintegrates itself spontaneously, and then that particular that property is what we call as radioactivity. Alright, now keep this in mind. A radioactive or radioactivity, it is never experienced or it is never caused by an external agent. Whatever it might be, pressure, temperature, humidity, stress and strain, you take a radioactive element, you start hammering it, doesn't mean that it's going to make it radioactive. Okay, any sort of chemical reaction, nothing doing. Whatever occurs because of this, this radioactivity or radioactive emission, it is because of the instability of the nucleus. Fair enough? Now the next thing what we have is that who exhibits this radioactivity? Who, in the sense, we are talking about nuclear level, isn't it? Who exhibits these things? First option, a very clear option, heavier nuclei. Okay, when we say heavier, atomic mass greater than 150, they exhibit this radioactive property. Okay, the reason why they cause, what is the reason behind it? Okay, so we are talking about the cause of radioactivity, isn't it? When we talk about the cause of radioactivity, a very simple thing comes into play. That is electrostatic force. Okay, electrostatic force. So first point, obviously the binding energy per nucleon has to be lesser. Correct? It decreases. Heavier and heavier the mass, lesser is the binding energy per nucleon. You guys already know that. The second point is what? See, as the mass is going to become bigger and bigger and bigger, between two protons, they are going to have electrostatic force of repulsion, correct? And since the distance is very, very small, the electrostatic force is going to be very high. So because of this, there's going to be a little bit of clash between two particles within the same nucleus. This causes a lot of disturbance within the nucleus. I'm putting everything in very easy layman terms. Okay, and because of this, that instability in the nucleus is going to occur. This is the cause for radioactivity. Okay, now this is the cause for radioactivity. So three things we understood. What is radioactivity? That one, first one, it's a spontaneous event, correct? It's a spontaneous, undisruptive event which is going to occur within the nucleus. Second, who causes this one? Second one, what elements exhibit radioactivity? Heavier elements. Third parameter or the third point, what we learned here, what causes radioactivity, correct? What causes it? It's the unstable nucleus, and for that instability, we have electrostatic force of repulsion to blame, correct? So these 3 points you have learnt in this particular video. Now, whenever there is this radioactive emission, what do they emit? Okay, that we'll understand in the next video.